Let's talk about arrays. Why arrays exist? Imagine storing 5 student marks, right? Without an array, using this, we store 5 students marks, right? Normally, an array is declared like this, okay? With arrays, we can represent multiple values under a single name, making your code cleaner and more powerful, right? What is a 1D array? 1D array in Java is a container that stores multiple values of the same data type in contiguous memory, right? Accessed using index numbers, right? Java arrays are zero indexed. Why do we tell Java array are zero indexed? Because the index is a measurement of distance from the start, right? Imagine the array is a row of houses, right? You are standing at the very beginning of the street, right? Index 0 mean you are at the first house, right? You have moved 0 steps from the start, right? Index 1, you move 1 step over to get to the second house, right? Okay. Index 2, you move 2 steps, right? Over to get the third house, right? See, 1, 2, we can get the third house, right? Okay. Why computer do this? Direct math. It is faster for the computer's brain to calculate where data is stored if it doesn't have to subtract every time, right? Okay. Second one, the offset. In the computer memory, the index tells the system exactly how many slots to skip to find the data you want, right? Remember, the first element is at index 0, right? How can we get the last element's index, right? At this time, the array's size or length is equal to 5, right? To get the last element's index, we must subtract 1 from the array's size or length, right? Okay. We can declare a 1D array as this, right? From this, you are telling Java, I need a variable named marks that will hold a list of integers, right? This links the name to the actual storage space, right? Okay. New. This is a build command. It tells Java to go into the computer's memory and carve out a brand new space, right? Okay. This specifies the size. It creates exactly 5 empty slots for numbers, right? Okay. We can assign a value to an index as this, right? See, this is index. This is the value of index, right? Okay. Instead of this, we can directly declare and assign values as this, right? Okay. In this case, Java automatically sets the size is equal to 5. Okay. How can we access elements? Inside the print method calls the variable, right? Marks, and put the square brackets like this. inside the square brackets, you should give the index number like this. I give it as 3, right? Now it should print 65. 0, 1, 2, 3. Third index, right? Okay, let's see. Now you can see our output, right? Okay. Using a for loop, we can print all elements, right? Start from 0th index and runs until the array's length, right? And increment. Using this, we can print all elements of array, right? In this case, I is a variable that changes every time the loop runs, right? First pass, it is a 0. It prints marks 0th index, which is 35, right? Second pass, I becomes 1. It print second item, right? Okay. Then we can print elements from this method as well, right? From this we can start the process, right? IntTemp creates a temporary variable named m to hold the current number being handed to you, right? Read this as in, right? Marks the array we are looking through, right? Okay. Look at this array, right? First handoff, Java grep 35 puts it into M, right? And runs the code inside curly braces, right? It prints 35. Second handoff, Java grabs 100, puts it into M and runs the code again. It prints 100, right? Remember these points. Array size is fixed. Index start from 0, right? Okay. And marks length gives size, right? Okay. Marks length equal to array size. Okay. Remember these things. Okay. Let's check out and out of range index, right? You should add 1 to marks length, right? It means size should be 6, right? But fixed size is 5. You can't add anything, right? Okay. Let's run it. See, it gives array index out of bounds exception, right? It gives that error. Okay. What is a 2D array? A 2D array is basically an array of arrays, right? Think of it like a table. Look at this. We have 3 columns and 2 rows, right? We can declare a 2D array as this, right? This tells Java you want a grid that will hold whole numbers, right? Matrix. This is just the name you have given to your table, right? And this, right? This sets the size of the grid, right? The first number 2 is the number of rows, right? The second number is the number of columns. Okay, rows, columns, right? This matrix can hold 6 items in total. How can we apply this, right? Since it's an int array, Java automatically fills every slot with a 0 unit. You change it 0 until you change it. Okay, we initialize the array with values as this, right? Okay, we can represent 2D array like this, right? To access a value in a 2D array, you are essentially providing the address of a specific cell using 2 coordinates. There are rows and columns, right? Okay. Remember, the order is always row, then column, right? First, this one. Look at the second row, because we start counting at 0, right? 0 means look at the first slot in that row, right? Okay, like this. See, it gives 1 and 0. Look at the second row, right? And first slot in that row. This is the first slot, this is the second row, right? Okay, it should give 58, right? See, okay, we use a nested loop to print all elements in this array, right? Okay, this is the standard way to visit every single cell in our grid. Think of the 2 loops as a scanner. The outer loop, right? This is the row scanner, right? It starts at row 0 and doesn't move to row 1 until the inner loop is completely finished, right? Okay, next one is inner loop. Inner loop J, this is the column scanner, right? J is the column scanner. It travels across every seat in the current row, right? Exactly what happens if I is equal to 0, it means row is equal to 0, right? J goes 1, 0, 1, 2, it prints everything in the first row, right? System out.println, moving the cursor to a new line, right? Okay. If I is equal to 1, now row is 1, right? Then J goes 0, 1, 2, it prints everything in the second row. This hits again, right? Okay. This tells the loop to stop after the last row, right? This tells the loop how many columns are in that specific row, right? This uses the current row I and current column J to grab the specific number at that spot, right? Instead of a long vertical list, the system out.println at the end of the first loop ensures your output looks like a real grid on your screen, like this. Okay. If we want the numbers to stay on the same line with spaces between them, like this, right? Change the inner line to this, right? Notice I used print instead of println, right? Okay. Remember, first index is a row, second index is a column, right? Max length, matrix length, right, is number of rows, right? And these number of columns in row I, right? Let's find the minimum value in a 1D array, right? How do humans find the minimum of this, right? Look at all numbers and keep the smallest in so far, right? We will teach Java to think the same way, right? To find min or max, you must start with the first element, right? And compare it with every other element. Never start with 0 blindly, that causes bugs, okay? Assume the first element is the minimum, right? Assign the first index value as the minimum, right? This code is the standard way to find the smallest number in a list. Think of it like a survival of the fittest competition, right? Where the fittest is the smallest value, right? We start at the second item because we already assume the first item is the smallest for now, right? The if statement. The loops look at the current number num I, right? Okay. It asks, are you smaller than the smallest number I have seen so far, right? If the answer is yes, the old min is tossed away and this new smaller number becomes the new min, right? Okay, let's run it. It should give 8, right? It is the minimum value, right? See, okay. You can find the maximum value by changing these things, right? First, you should change this to max, right? And max max right. Flip this symbol like this and make it max and give max. Now you can find the maximum value of array, right? See? Okay. Why start from index 1? Because min and max already holds nums 0, right? See? Okay. Comparing it with itself is useless. That's why we start from index 1, right? Let's move on to the searching elements, right? Searching means checking whether value exists in an array and optionally finding its positions, right? This code is a basic linear search. Think of it like looking for a specific book on a shelf by checking them one by one from left to right. Okay. This is our shelf of numbers, right? This is the book we are looking for, right? This is a flag. It starts as false because we haven't started looking yet, right? The loop acts like our finger pointing at each number, right? This should be 0. Okay, sorry. Counting starts from 0 and starts looking at the second number. It asks, is this number equal to 89? When it reaches I is equal to 3, the if statement becomes true, right? It prints found it at index plus I, right? Sets our found flag to true and uses break to stop looking immediately, right? If it is not, this runs until infinity, right? At this time, our flag is true. Therefore, it gives found it at index 3, right? What about this? Skip this if statement and it gives not found, right? Okay. Let's look at the inner loop J. This is the scanner. It walks down the array, right? Comparing two neighbors at a time, num j and num j plus 1, right? Inside the inner loop, the code asks, is the number on the left bigger than the number on the right? If the answer is yes, they swap places using a temporary variable, temp, right? Okay. Put the left number in a temp box. Move the right number to the left spot. Put the temp number into the right spot, right? Okay. After the loops finish, the array is sorted, right? The final for loop simply prints out the result like this. See, it is already sorted, right? What is a string? A string is a sequence of characters. This is an example, right? Strings are immutable in Java. It means once created, they cannot be changed, right? We can access characters using this, right? This is a command. That means give me the character at a specific position, right? According to that, this should give U, right? 0, 1, 2. Output is U, right? This is a command that counts every single character, including letters, numbers, spaces, and punctuations, right? Okay. It should give 5. 1, 2, 3, 4, 5. We have 5 letters, right? Okay. You can see output as 5, right? This is the standard way to check if two pieces of text called strings contain the exact same characters, right? Think of it as comparing the content inside two different envelopes rather than the envelopes themselves. Equals. This is a command that tells the computer, look at every single letter in S1 and compare it to the letters in S2, right? If they are matched perfectly, the condition is true, right? See, you can see S1 and S2 is equal. Therefore, condition is true and it should give S1 and S2 are same, right? See, okay. You can't use this, right? You can't use this instead of equals, right? Equal checks contents, right? This one checks memory allocation, right? Sorry, memory address, right? Just remember, equal method is picky, right? It considers apple and apple to be different, right? If you want to ignore capitalization like this, capitalization, use equal, ignore, equals, ignore case, right? You can ignore capitalization, use equals, ignore case, right? Right. See, okay. Now I want to capitalize these words, right? How can we? Name dot to uppercase, right? Then run it. Give it inside the give it inside the south, right? South means system.out.println, right? South. Let's see. See, all are capital, right? If you use to lowercase, all letters are simple. See, okay. And you can use contains inside the parenthesis. You should give LNG, right? And run. It gives true because this word has LNG, right? That's why it gives true. But if you give Nimesha, it should give false, right? Because these words haven't any Nimesha, right? Okay. Using substring, it starts at the first letter, index 0, right? And grabs everything up to but not including the 6th letter, index 5, right? Giving you the first 5 characters, right? You can see like this, okay? This is the big problem with string, right? It looks simple, but what really happens? Java creates new objects every time. old strings are discarded, right? This is slow and memory wasting, right? Why string builder exists? String builder is a mutable string, right? That means we can change it, no new object created each time, much faster, right? We can create a string builder like this, right? You should create object from string builder class, right? And inside the parenthesis you should give any text. Okay. How to append string to hello? sb dot append string should use this right, and print sb now. Now you can see hello is right. Okay. This freezes that work in progress into a finished piece of text, right? The result is the new variable that stores that final unchangeable text so you can use it elsewhere in your program, right? This code inserts the text hey hey into the word hello starting at index 2, resulting this, right? Okay. Index 2, h1 index 0, e index 1, l2, l3 and 4, right? Okay. In the word h index of h is 0, index of e is 1, index of l is 2, index of 3 is index of l is 0, 1, 2, index of o is 4, right? In 2 is the position of the first term, right? See, 0, 1, 2. This is the first term, right? Okay. It pushes everything from index 2, right, onwards to the right and drops hey hey into that gap, right? Push everything from index 2, right? Index 2, push. And insert the hey hey into that gap, right? Okay. From delete method, this is the start and this is the end, right? Start from L and end from O, right? It means you should delete second index value and third index value, right? Okay. Wait. This code removes the characters starting at index 2 up to index 4, changing hello into HEO like this, right? The characters at index 2 and 3 are double letter, right? Okay. It cuts out, it means delete, cuts out those two characters and shifts the O back to join the HE like this, right? Remove double letter. What is the rule of this? Just like substring, right? The first number is inclusive, right? See, first one is inclusive and the second is exclusive, right? To find out how many letters were deleted, just subtract 0, 1, 2, 3, 4. 4 minus 2, right? It gives 2. It means 2 letters removed, right? We can reverse these things using reverse method, right? See? Okay. If you get something from this video, don't forget to subscribe us, like, comment and share with your friends. Bye-bye.